Hey everyone, did you know that all of the information that is present currently right now over the internet, 90% of that information was developed in the last decade or so? And and you've seen that data engineering has grown massively over that time. Hello everyone, this is Sumar and I work as a global Google Cloud practice head where I overlook all of the Google services within Royal Cyber itself. uh, I would like to, share a bit of a background on my end. So was one of the early adopters of Google Cloud with more than 10 plus years of experience. My personal favorite interests are all about data mitigation, migration, and data security. I also love to design and build event-driven serverless architectures. Have the privilege of working with one of the very, famous Fortune 500 companies, build great solutions for them, and nonetheless love to do tech evangelism. With me is Mustafa Ali Mir, and basically, he's our data engineering specialist, and also he just loves working with machine learning and AI. And also, he has like more than 3 years of experience, but that does don't let that number fool you, right? So you might as well just put a zero right after the three. So he's like a 30-year-old, experienced guy with accumulated into three. So he just loves building operational size, large scale, data operational solutions, and just, is a big fan of Google Cloud itself. So before we actually dive on to and just talk about the main major topic of the webinar itself, I would just like to go a bit of background on Royal Cyber itself. So we are a ID solution and digital transformation company where we've been working in the industry for more than 20 years, have more than 1,500 plus employees spread it out globally, have our presence in 5 continents with over more than 10 plus countries, and also have more than 250 certified resources with 600 plus clients. All of those clients are actually from Fortune 500 companies. Some of the clientele that we've actually served over the years and the different verticals that we've been a part of, like manufacturing, automobile, healthcare, travel, supply chain. So you name it, we've actually touched all of those different verticals. And these are some of our badges that we're really proud to showcase. Some of the business partners that we have, namely, is Google Cloud itself, my personal favorite. And these are some of the partners that we've worked over the years and are currently working with now as well. So before I actually move on and talk about, the major aspect of the webinar itself, I want to highlight some of the major challenges or the major questions that that basically our customers come to us with. And those, so some of them are like, how do I is the ecosystem large enough for me to support my needs, or how do I take advantage of AI/ML technologies without building a huge data science team, or how do I scale up the solution with my business, or how do we deliver insights rather than infrastructure? And my personal favorite is how do we govern, democratize, and how do we do handle compliances when it comes to handling this huge amount of data? So we've actually come across, and again, this is all backed up with our huge, vast experience working over the cloud. So we've actually come across, one single solution, and basically this solution was actually provided majorly from Google, and we just, tried to expand over it. And that is what we like to call smart analytics. So smart analytics is basically a complete package of all of the different Google Cloud services jumbled up together, where we can, utilize them for any particular use case when it comes to understanding the data, processing the data, and then making sense out of that data. So we basically utilize all of these great services from Google itself and jumbled up together. That's what we call smart analytics. The link is in the slide if you guys want to read more about smart analytics, but we'll go over this, this presentation where we're going to dig more deeper into what actually smart analytics is all about. So if you talk about, the smart analytics approach, it basically accumulates into 5 different sections. So you have capture, process, store, analyze, and finally use. So when we talk about capturing that information, you have different services like PubSub, storage services, cloud IoT, or when we talk about processing, we have data flow, we have data prop, we have data prep. when we talk about storing that information, either we use BigQuery storage or we use cloud storage for that, or any of the databases that we feel deemed with. Or when we talk about analyzing, that's where one of my favorite tools comes in. That is BigQuery. And when we try to use that, we either use that using any BI tools like Looker, Sheets, TensorFlow, or Cloud AI platform. So basically, smart analytics approach is all about using all of these different services jumbled up in a sequence where you can get the right information by ingesting the right amount of data and then making sense out of the data so that you in the future are able to make the right decisions for your company and be able to predict how and where my business is actually going for. So when we talk about, in terms of how smart analytics actually enables business transformation, that when we talk about ingesting data, right? And data can be produced from multiple sources. So like, it can be, you could have a project which is basically an IoT based application where you have a lot of different sensors who's actually sending, reading, and sending out data to the server, or you have a lot of employees who are just crunching out numbers and you're just reading that information out. Or maybe you have a sensor who's actually, like, so sort of like a step sensor, and just to understand, how many people are visiting your stores and how many of them are going out. So data sources can be of different, can be of different aspects, right? So either that data is going to be streamed, or that is data is going to be in a batch scenario, right? So in terms of, ingesting that data, we use different services like PubSub, data transfer, migration services. Once we collect that information, we then process that information so that we're able to make sense out of that data which we have. Because once the data is collected, it's completely in a raw form where, not a lot of sense would actually be made. We actually tend to convert that data into information. That's where we use different ETL processes for, like, let's say, where we utilize data fusion, we use data flow and data proc for processing that information, and then finally we use data prep for wrangling that information. Once the process is done, we tend to store that information into any of our, databases, storage services that Google Cloud has. So once that data is stored, we send that information over to getting analyzed. And this is where one of my favorite services very hugely used, that is BigQuery, where we can just, analyze that information, run the right amount of queries out on top of it, just to get the right information out of it, and then send that response into any BI tool. My personal favorite is Looker. So basically, we send that information over to Looker, where those insights are converted into these beautiful charts, and you're able to understand, and you basically have a complete snapshot of what your business currently looks like, and what's the next step when we're trying to, make the right decisions so that your business can grow over the years as the market is going. Or you might want to right step, right? Or should I say, not in the right shape, right? So it's all about making the right decision, getting the right information out of it, right? So all of this information that I just shared with you, this is all backed up with 15 years of tackling with big data problem. So Google Cloud might be, we would say, if we talk about the big three, might be new, but that doesn't mean that Google Cloud doesn't know how to handle big data, right? I mean, just look at Google itself. I mean, their one product, the Google search engine, generates so much information in terms of petabytes itself in just a day or two. So they really needed to work that out. So they've been working behind the scenes on big data solutions from the very get-go, right? So here, you can see a lot of different, household names in terms of, data prospects, which is Hadoop, Apache Base, Drill, TensorFlow, Beam, right? But all of those similar services are now currently available for the Google Cloud Platform itself. So we have BigQuery, PubSub, Dataflow, which are like synonym services which you can utilize using those open source versions as well. So all of this have been accumulated over the years in a span of 15. I know this slide is till 2018, but we can add 4 more to that. So that's like 15 plus 4 to 19 years, right? So in the end, Google Cloud's been going strong, right? Ever since from there, just to understanding the right amount of data engineering services for our use cases in the business and being able to generate the right decisions when we're talking about that raw information converted into the right information. So who can value from smart analytics? So some of the common use cases that can actually go for this approach is, let's say you want to decrease your costs. So one of the major challenges that we face we've always seen with our customers is that they just want to reduce it. So they would rather, they have like this huge amount of data that's resting on-prem, and they just want to bring that over to the cloud. But the core challenge is that, it's a very costly process, right? That's just one use case. But there are a lot of other use cases where you just want to tone down the cost itself, or you want to improve the overall user experience. So you're just talking about the overall aspect of data engineering itself. Like just understanding, ingesting, and then giving out the right information to the customer over the dashboard. You just want to improve that experience and being able to just map out the right stats, right, the right insights, or increase productivity, or maybe you just want to do some innovation and just do some major transformation with your business. You want to just completely go from on-prem to the cloud itself, and that's where smart analytics can really help you out solve those problems. So one of the favorite, like I've been constantly saying that Google BigQuery is one of my favorite services, and I think now is the right time to talk about it. So BigQuery is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data. So what that actually means is that it can actually analyze huge petabytes, zettabytes of data, and then generate the right information or the right insights out of that data, which can later on be ingested into BI tools to give you the right insights, to give you the right snapshots of your business. It uses ANSI SQL, which is like your normal SQL that you normally use, and just utilize that SQL over to basically uh, to basically extract the right information. And finally, it also has like machine learning capabilities. So there's a service called BigQueryML, sorry about that, which my partner is actually going to talk about later in the session. So that's one add-on service on BigQuery itself. So BigQuery in a nutshell is like an enterprise data warehouse, can be scaled up to petabytes, has encrypted durability, fully managed serverless service, and basically can create real-time insights, and basically has built-in machine learning capabilities and in-memory BI engine as well. Some of the areas that BigQuery can actually be used for ingesting information, as you can see in this diagram, there are a lot of inputs, right, where you can ingest a lot of information from different sources. Once that information is ingested into different ingestion tools, those tools can then send out that information or that data over to BigQuery, where BigQuery can actually analyze and just give you the right responses, utilizing its powerful query language and its powerful processing aspects of things. So in a nutshell, BigQuery is basically a modern data warehouse that enables you to, number one, automate data delivery, democratize data insights, build the data foundation on AI, tee up real-time insights, protect your business, and then finally, last but not least, over simplifying your data operations, right? So these are all of the different aspects of what basically you can do using BigQuery itself. Finally, in the end, I would like to do some comparisons here. As you can see, when we talk about all of the different tools that are available in the market, like Teradata on-prem, AWS Redshift, Snowflake, Azure Synapses Analytics. So if we compare that with BigQuery itself, you can see all of the green tick columns, right? So it's all, whether you want to talk about scalability, whether you want to talk about real time, whether you want to talk about AI support, or you want to talk about data security itself. So you can actually tone down in all of these different sections, and you can actually work on basically all of these aspects of the data engineering, of the BigQuery paradigm. So finally, this is just an insight just to help you guys understand that how you can actually to reduce your total cost of ownership of the data itself. So these are like some of the insights being shared for Teradata on premises, Teradata on AWS, and then finally Google Cloud BigQuery. So you could see that there's a 52% lower TCO when compared with the last two, and this data has actually been provided just from Google itself. So you can vouch on that this is the right information that is being actually presented over here, and this is actually about creating the right the right insights for the data itself, right? Finally, I would just like to add a few little pointers on BigQueryML. Like I said, that BigQuery has a tool on top of it called BigQueryML, where you can do personalizations, predictive maintenance, future demand predictions, and then finally sentiment analysis. analysis. My partner Mustafa Ali would actually go a lot to this. Up until now, guys enjoyed what I've shared with you in terms of Google, sorry, in terms of BigQuery. I would like to hand this over to Mustafa, who would actually be explaining you different use cases using BigQuery and BigQueryML, and dive deeper into some of the use cases that we've actually come through while we're working in the company and how we've actually helped our clients do it. Thank you so much. Over to you, Mustafa.
Thank you, Sumer. Let's discuss about the use case first. As we all know, the retail business always face inventory challenges in supply chain or procurement. Also, the coronavirus has presented a lot of unique challenges in supply chain worldwide. So it's important to understand the impacts of these closure on supply chain. Suppose your business specializes in selling fresh products and you want to minimize the food waste and to optimize the stock level across all the stores. For that, we are doing demand forecasting to solve these inventory challenges and to enable companies to take faster and better data driven decisions. So the role of forecasting in supply chain is to predict future outcomes and discover new opportunities within your business. The strategy we follow in our supply chain our production, where we schedule, we take care of our inventory, we carry out our plans. In marketing, we have sales allocation, promotions of our previous products, new product launches. And finance, we have to invest in our equipments and plants. We carried out our budgetary planning. In personal, we have human resource management, new hirings, and layoffs. The business use case is to predict future outcome accurately and discover opportunities. It is designed to create 3 months demand forecasting model to predict customer desires in real time. We have the data of 10 different stores and we have 50 different products. As the legacy system we are unable to scale their stack, we cannot perform machine learning on a legacy system as the data are in silos and we cannot prepare our data for forecasting and analytics. The customer has multiple data sources as the data is coming from 10 different stores. They are different vendors and suppliers. So the solution which we suggested is to bring the data in the BigQuery from multiple data sources. Since our data is in BigQuery table, we don't need to migrate our data to build and operationalize our machine learning model. We get the insights real time from our BigQuery ML forecasting model using Data Studio. The benefits which we get is scalability, real time forecasting. We minimize the cost, we maximize the profit. So what is basically the BigQuery ML? The BigQuery ML is to execute our ML model without moving the data from BigQuery. We iterate on the models using SQL in BigQuery, which increase our development speed. We can automate our ML task using hyperparameter tuning. This is basically the architecture of our demand forecasting model. Whenever the user come and scan for a purchase, it goes to our operational database. And that database is real-time replicated using data stream. The data flow ingest the data and store it to our BigQuery table. Since our data is in the BigQuery table, we can create BigQuery ML forecasting model. And the forecasting is visualized in our data studio. Let's go to the dashboard. This is our dashboard look like. So we have the total records, we have total sales, we have the average sales. So the total records are around 9,13,000. Our total sales are 47 millions. Our average sales per day per item is 52. So as you can see, the most purchased items are here, item 15, 28, and 13. So here we can select the dates, we can select a specific item, we can select on which specific store we want to see the data, we want to forecast. So this is what our actual data looks like. So for example, I want to see only store 2. So as you can see, the top 3 item sold in store 2 is item 28, item 15, and item 18. Now if you want to check which are the top most items sold in store 3 is item 15, item 28, and item 13. There is no item 18 here. So if if we want to see on the specific date, like if we want to check from January 13 to March 13 only, and apply the filter here, and I want to check only item 15 sales here. So this is our 2-month data here from January 2013 to Feb 2013. So our historical values are 533 items were sold at January 14, 2013, January 4th of 2013. Now, how we created our model. So this is our data looks like. We have the date column as we are doing a forecast. So we have the date column which is basically a timestamp. We have different store IDs. We have around 50 items here and the sales on that specific date. Now let's move to forecasting. How we forecast our data. So as we have long-term forecasting and we have the short-term forecasting, here we are doing a 3-month forecasting, which is basically a short-term forecasting, as long-term forecasting are less accurate than the short-term forecasting. How we decide the forecasting dates is the forecast horizon. So here you can see 90. So basically the horizon is a time point to predict in the future. Here we are specifying 90, which means 90 days or 3 months. In time series forecasting, the prediction intervals, which I will just show you, which is captured by a lower and upper bound, is basically important as a forecasted value. Here we are setting our horizon as 90 and the confidence interval is 80%. We'll talk about confidence interval later. Now, if I run this query, I will get a result like this. The item 1 on store ID 1 on this specific date, the forecasted value is 24. And we have our standard error and confidence level. We have some lower boundary and upper boundary. So the prediction interval depends on the standard error and confidence level. So if I tune this confidence interval, our this lower boundary and upper boundary will change. Okay, so let's talk about this confidence level. How we set this confidence level and what confidence level should we use in which specific use case. For that, we'll just go back to our forecasting dashboard. So this is our dashboard looks like. Now select the date. We want to check the data from 2017 of December 1st till 2018 March, as we have the data to December 31st, and we are going to forecast for January, Feb, and March. Okay, so this is what our forecast looks like. Our total records are 60,000. We have total sales of uh, 695,000, and we have average sales of 44, and our forecasted average sales will be 49. And we have this lower bound of 1.8 million, and we have our forecasted sales around 2.2 million, and upper bound is 2.6 million. So this is our historical data, and this is our forecasted data. Now if we want to check for a specific uh, item, I'll select only 15. I want to see our item 15 on store 2 only. So what will be our forecasted value of our item 15 on store 2? So this is our historical data, as you can see here. Now this is our forecasted data looks like. So um, in this specific date, which is 1st of March 2018, our forecasted value is 137 units. Our lower boundary is 124, and our upper boundary is 150 units. So to understand this confidence level, I'll take back to the slides. So this is our confidence level look like. If we set a lower confidence level, we'll get a lower boundary within your forecasted value. If we set higher confidence interval, which is 99%, you'll get a higher boundary around your forecasted value. So let's take an example. Suppose you're working for a retailer which don't want to lose single customer, as that buyer might become a regular customer in future. So you want your model to be 99% accurate to make sure the availability of that product. Then you will use a higher confidence level, which in this case is 99% accurate. So you'll make sure that the item 15 is always available on store 2. Now suppose, let's just assume you don't have a large warehouse for your inventory, or you don't want to or you just want to optimize your warehousing cost. In that case, you want your model to be predict nearly accurate or just close to your forecasted value. Then you will use a lower confidence level, which is here in 80% confidence interval. So this is the confidence interval. So let's say the capacity shortage may result in undependable deliveries. You will lose your customer, you will lose a market shares, you just lose to generate revenue, as you cannot stock too much, as some products have expiry dates. We might face logistic and warehousing problem, and it can be costly too. So this is totally based on your use case of what you want. If you go for a lower confidence interval, or you want to go with a higher confidence interval. So that's it from my side. Hope you get valuable insights. Thanks for being a part of this webinar. You can always connect with us at royalcyber.com/technology/Google Cloud Platform, or you can simply email to rupesh.sunkar@royalcyber.com. If you have any questions, feel free to ask.